Lab 3 in Unit 2 is the respiratory system. So what we're going to do is we're going to start at the top of the respiratory system. Some of this will be review from the digestive system, and then we'll move down into the lungs as we go along. So normally air enters our respiratory system through this opening in our nose that we call an external nare, or we can call it a nostril. Just inside of this opening there is a space or a cavity that we call the vestibule. And the vestibule is an area where air first enters. As we age, we get more hair in this area, and mucus tends to dry out in this area as well. So the air that's being brought in through the vestibule is actually eventually going to be brought over 3 folds. Now, if you'll recall, we studied these folds when we did the skull, and they are folds of bone that increase the surface area for our olfactory epithelium. And so we have the superior turbinate, the middle turbinate, and the inferior turbinate. And then just as a review, the superior and the middle are on the ethmoid bone, and the inferior is on the palatine bone. So because these folds fold medially into the nose, they divide the nose into little tunnels at this point. So these tunnels are called meatises, and so we have the superior meatus here, we have the middle meatus here, and we have the inferior meatus here. And they're called turbinates because they make air roll as it's passing through over these surfaces, which greatly increases the contact with the nasal epithelium. That's much more important on the superior and middle than it is on the inferior concha. And then, as you'll recall, our eyes drain lacrimal solution via the nasolacrimal duct to underneath this inferior concha. So that helps us moisten this air as it's passing through this space. Now, the openings of the meatus right here are called internal nares. So where we have only one external nair on each side, we have 3 internal nares on each side. Or we have 2 external nares in our nose and 6 internal nares in our nose. Now, this opening then is to another space right here, which we call the nasopharynx. So the internal nares open to the nasopharynx. And then there are several things that are associated with our nasal passage. So this hole here represents the opening of the eustachian tube. And recall the eustachian tube goes to our middle ear chamber and helps us equalize pressure across our tympanic membrane. And then associated with this, we also have paranasal sinuses. So one of our paranasal sinuses that we're seeing here is in the frontal bone, so it's the frontal sinus. This one represents the paranasal sinus in the ethmoid bone, so that's the ethmoid sinus. And then this represents the paranasal sinus in the sphenoid bone, or the sphenoid sinus. This ethmoid is actually a little too posterior, should be more anterior than that. So it's a little confusing. So as you'll recall, our oral cavity is separated from our nasal cavity by the palate. So we have bones that form the floor of our nasal cavity, or the roof of our mouth. So we have the palatine process of the maxilla anteriorly and the palatine bones posteriorly. And then we have the soft palate, which extends down to the uvula. So our nasopharynx continues on to the end of our uvula. And then at the end of our uvula to the top of our epiglottis here, we would have our oral pharynx. And then from the top of our epiglottis to the end of the opening in the larynx right here, we would have the laryngopharynx. And so even though food normally passes through the oral pharynx and laryngopharynx, air passes through all 3, the nasopharynx, oral pharynx, and laryngopharynx. And then recall we have a sphincter at the top of our esophagus called the superior esophageal sphincter. And that prevents air from passing down into the esophagus when we're breathing, so it closes off. And then the epiglottis, which would be brought downward and close this opening off while we're swallowing food, it recoils upward to be open. So now the air enters our larynx. Now, as we enter our larynx, we actually have two folds that we can see here. An upper fold, which is the false vocal fold, or what we say is the vestibular fold, and then this bigger, larger fold below that, which we call the true vocal fold. And notice there's a depressed area between those two folds, which we refer to as the laryngeal sinus. And so we have the true vocal fold, the false vocal fold, and the laryngeal sinus. Now, what supports the larynx are cartilages. So the epiglottis is a cartilage that is above the larynx. This is called the thyroid cartilage. And as we'll see in another model, the thyroid cartilage is incomplete posterior. And the second cartilage we're seeing here is the cricoid cartilage. And the cricoid cartilage is the big cartilage we also see posterior that give the wall of the larynx its structural support. So one thing we can't see, because this is a mid-sagittal section, is that our nose is actually separated into two sides. So as we said, we have one nostril or external nair and three internal nairs on each side. So if we look at this skull, then you'll recall that there's a septum that separates the nose into left and right sides, and the upper part of the septum is created by the perpendicular plate of the ethmoid, and the bottom part of the septum is created by a bone called the vomer, and it separates our nose into two sides, left and right, so it's called the nasal septum. So this is our larynx that we were just looking at that was cutting cross-section. So the big cartilage we see anterior, which is the big bump you would feel in your neck, is the thyroid cartilage. And it gets its name because the thyroid gland is associated with it. The next cartilage we would see down, which we can see right here, is the cricoid cartilage. And if we look posterior, we'll notice that the thyroid cartilage is incomplete. It stops here. And so the big cartilage we're seeing posterior is the cricoid cartilage. And then we have two little cartilages that sit on our cricoid cartilage posterior. And notice right here there's a little division here and here. So we're seeing the upper part of a cartilage that's a big triangular cartilage, which would be called the arytenoid cartilage, And then sitting on top of the arytenoid cartilage, we have a little tiny cartilage called the cornuculate cartilage. Now, the opening through which air passes in the larynx is called the glottis. So the opening between the vocal folds is called the glottis, which is why this upper cartilage is called the epiglottis, because it is above the glottis, which is where it gets its name. Now we can see these same structures on this model, only all the muscle's been removed. So we have at the top the hyoid bone, which supports this structure. We have the thyroid cartilage, which is this major cartilage anterior. Then we have the cricoid cartilage, which is the smaller cartilage below that. Then below that we get to tracheal cartilages that support the trachea. Now as we rotate it around posterior, we'll notice that the thyroid cartilage is incomplete, and the large cartilage that sits on the back of the larynx is the cricoid cartilage. And then sitting on the cricoid cartilage, we have these two larger triangular shaped cartilages, and you can see the division right here where they stop are the arytenoid cartilages. And then the two cartilages on top of that are the cornuculate cartilages. And then on this model to show you that the epiglottis can change shape to close off the airway, they put it on a little spring here. So when you were swallowing food, it would close off this airway, and then when you want to breathe, it springs back inward. Now what they've done with this model is they have put in it the true vocal folds. So we're seeing the true vocal folds here. And when we're swallowing food, we close them off, but then when we're wanting to breathe, we open them again. And so the opening is called the glottis. And so here the glottis is closed for swallowing food. Here the glottis is open to move air. So notice that the role of the arytenoid and cornuculate cartilages are actually designed to help with support the muscles that allow us to change the tension on our true vocal folds and allow us to open the glottis or close the glottis. So if you were telling someone, hello, then your glottis would open and close as you create that volume airflow. So what we were just covering was the larynx, which is the top of this. And that's where air enters it. So what we're seeing here is the trachea, and the trachea have little cartilage rings. Because we breathe by negative pressure, it would cause these upper airways to collapse. So we have to have cartilage wings that prevent that from collapsing. So as we move downward, this one common tube, the trachea, has to bifurcate because it has to carry air to each of the set of lungs. And so it bifurcates and creates what we call primary bronchus. So here's a primary bronchus and here's a primary bronchus. And then what we have is a triangular piece of cartilage here that exists at the end of the trachea where this bifurcation occurs, and it's called the carina. Now, as we move out, then a primary bronchus is going to branch and create two secondary bronchus. And then a secondary bronchus is going to branch and create tertiary bronchus. So we have a trachea, a primary bronchus, secondary bronchus, and two tertiary bronchi we're seeing here. Now, what happens is that's the level at where cartilage exists. So as we move out on the model, we'll see that cartilage actually disappears. So we have two divisions off of this tertiary bronchus. And notice that when we look at them, they're together and then they branch. So the division that's together is called a bronchioli. And then the branches off the bronchioli are terminal bronchioli. Now, interestingly, as we go forward, we're going to see that terminal bronchioli actually have some more tubes. But this is all you could see with your naked eye. So with early dissections, then they thought this was the end of the tube. So that's why it was called a terminal bronchioli. But we're going to see that they actually subdivide further. So when we're looking at the model, then it's just a pattern of subdivisions going from primary bronchi to secondary bronchi to tertiary bronchi to bronchioli to terminal bronchioli. So on this